let's get this started. So, it's been a couple of days since my last stream. Had some really, really bad weather in the local area on Wednesday. So, 2 days ago. Um, Terrible thunderstorms, tornado watch, power outages, the whole shebang, right? And so, of course, that wasn't going to be good conditions for a stream. And literally, like, while I was trying to let people know that I was going to cancel the stream, we lost power. So, I mean, it wasn't down for long, but it just didn't make sense to start a stream if there was a chance it might go down again, right? Today, no problems, weather's clear, so no blockers on that front. Now, what did I get done since last stream? Not too much. Been focusing on sort of getting my workout routine up and running, and tightening up some stuff around the house. But I haven't been completely unproductive. One of the things I worked on, oh, there's some interesting behavior going on there with that little tater bot. Oh, I think I know what happened. Yeah, as you can see, when they're wandering, they can go into the barn, which we don't want. They've been slowly... Oh, wait. Let me change views so that y'all can see what I'm talking about. We definitely lost a few guys to the process of us trying to get the bots to sort of like spawn in the garage area and then move on to the pasture. By removing that collider, we don't have to worry about them trying to navigate through it because it's not part of their nav mesh for that being open. I haven't updated it. But when they wander, they just sort of pick a random direction to move in. And that appears to cause issues with them just sort of exiting through the garage and falling off the map. Now, as far as what I did since last stream, I do have some stuff to show, some stuff I accomplished. So if I hit play again, one of the first things you'll notice is one of the drones started in the garage and exited the garage. We didn't have that up and running last time, so that is an improvement. It was something that I was working on and couldn't quite close up during last stream, that behavior of spawning someone in the garage, having them move on to the pasture, right? Now, there are still some pieces that are missing, but that being in place, that's good stuff. Oh, and I forgot to start recording again. Anyways, so, accomplished since last stream, cinched up some of the spawning and moving onto the pasture behavior, right? Didn't get much else done, though, so we can just sort of dive right into it. Now, there are a few things missing from being able to just spawn all of the drones in the pasture, having them move on, and then having them do normal stuff. One of the things that's missing is there isn't currently a function that will allow us to spawn them at regular intervals so that they can move in generally by speed value, right? We don't want to cause a traffic jam. And have them move in a systematic way. We currently are only just spawning the one drone as a test. Like when we click play, we just get basically one copy of one of the room bots, Bippy specifically, spawns and then moves in, right? And ultimately, we want all of the drones to move on to the pasture that way from the garage. Yeah, Bippy, says Lecturesize. So one of the first things we want to do is move away from having all the drones just on the scene and instead create a function that will go through that process of spawning them and registering them every at certain time intervals, right? So for that, we go into our drone spawner here, and we basically already have a little bit of code for this, where we basically are checking to see if we've completed our test. Then we do our test and mark it as complete, and that's that. What we want to do instead is have a function that gets triggered during process that sort of functions as a timer, where we're sort of accumulating up some sort of a time counter, and then once it hits certain intervals, we spawn another drone and we reset our interval, right? So let's start creating that function. First, we want a variable to represent how much time we want to elapse. And we're going to make it an export variable. Actually, let's not bother making it an export variable. We're just going to do... No, we can make it an export variable. It's not the end of the world, right? It'll be easier to edit if it's an export variable. Export var. We want this to be basically how many seconds do we want to wait in between spawned drones to spawn the next drone, right? I think 2 seconds would probably be a good value to start with, but we're going to name this guy something like spawn delay, or maybe spawn interval. We'll call it spawn delay. It's a float, and it's going to equal 2 for now, right? So we've got our spawn delay. Now we need a function for this. We want to, during process, so every frame, we're going to check to see if we should be spawning another drone. So maybe something like func check spawn, or rather, yeah, let's do check spawn delay. Something simple that we can just call every frame while we're spawning stuff. And we're going to do a bool for this, because basically for this drone spawner, we're pretty much going to, we don't want this check spawn delay function to happen every frame indefinitely. We only want to have it happen every frame until the starter collection is done, right? And since we are checking specifically the starters, right, this should probably be a starter related function here. So maybe check starter spawn delay, or check starter spawn rather. I like check starter spawn for this function. And now what we're going to do is we're going to add a bool around here. Var starter complete bool equals false. Cool. And it's going to sort of be just like our test complete check here. So it'll be if starter complete, return. Well, we don't want to kill the whole the whole process function on this guy just because we're done with the starter spawning, right? So maybe if not starter complete, then we do check starter spawn. That way, anything else we put in this process function will still happen. We're not just going to terminate it early like saying return would. Then inside check starter spawn, in addition to spawn delay, we also need var current spawn time float equals 0. So we're going to do inside check starter spawn, we're going to do if current spawn time, if it's greater than or equal to spawn delay, that's basically when we want to reset spawn delay, spawn the next drone, etc., etc. So we do current spawn time equals 0. Then we spawn a drone. We're not going to just slam it because we're going to need to do a little more work in terms of like tracking where we are inside the array, and stuff like that. But if current spawn time is not greater than equal to spawn delay, and actually before we even go there, we need to pass delta into this, right? So inside check spawn, or check starter spawn, we need to pass delta. Delta is the amount of seconds since the last frame. So by adding delta to our current spawn time in sort of a running way, we can sort of build up to our spawn delay value. And so as soon as we hit it or cross it, that's like, okay, spawn a new drone, reset it, and then keep counting. So we do current spawn time plus equals delta. That will just, it'll add the seconds up before we check to see if we've sort of elapsed our timer more or less. And if we haven't, there isn't really anything we need to do. But there are definitely certain things we need to do once we're doing what we're doing here, right? Now, we probably need a variable to track where we are array-wise inside our starting drones collection thing here. So let's do var starter index, maybe current starter index. And this is going to be an integer because we're dealing with the index of an array. I kind of feel like, let's see, if we start at 0, then we basically will need to spawn the drone at our current index, then increase the current starter index value, right? But only if we aren't at the last element of the array. So in the spawn a drone thing here, I think this would be a good time to do we definitely need to check to see if we're at the end of the array before we, well, if we're at the end of the array, then we still spawn the drone. If we're past the end of the array, then we stop, and then we're actually done. So what we want to do is we want to do if current starter index is greater than or equal to starting drones dot size. Oh, no, I don't need to do curly braces. Bad habit from C#. So if starter index is greater than or equal to starting drones dot size, right? That basically means, have we gone past the end of the array? Because size is going to count the number of elements in the array. But the last index is actually going to be one smaller than the size of the array, because 0 is the first element. So if there's like 5 elements, then the last part of the index is 4. So basically this part that I'm about to write is only going to trigger if we've spawned every drone that we can spawn from the starting list, right? So if we're greater than or equal to our starting drones.size, then what we want to do is set starter complete to true. Starter complete is true. And then I kind of want to say we do return, because we don't want to do the rest of this, right? then we can go else. So if we aren't outside the bounds of the array, then we go ahead and spawn the next drone and increment our index value. So we do spawn starter drones, and this is going to be starting drones dot starting drones, and inside this bracket it's going to be current starter index, then current starter index plus equals 1. That way the next time we spawn a drone, it's going to be the next thing in the array, or it will stop, one of the two. And actually, I'm pretty sure that does it, right? We have a thing that increases, we have a thing that'll reset it to 0, it'll do the thing, and it will cause it to eventually stop because it'll set starter complete to true. So now that we have this guy set up, that check starter spawn, and it's in here, I actually think we just slap return, because we don't want to do the test complete part of this process function anymore, because we're no longer testing. This is going to be the thing that does the thing, right? So this is that. Now that we're here, I think we get rid of all of the drones in the scene. Right? Well, what we can do is we can actually test it without doing that. I think that would be an okay thing to do. It does mean that we're just basically going to double the number of drones in the scene. Let's go to shot. Let's see how this goes. It may work. It may throw errors, right? There we go. 1, 2, 3, 4. Yeah. Okay. It's going. It's going. Now they are just sort of marching straight past where they're supposed to stop. But that's only because I set a direction for them. Okay. Now there's a bit of a traffic jam because they decided to join in and chattering. Now we have real problems. They're trying to spawn while they're all stuck. I think that was everybody, though. Okay. So I think while they're positioning, they definitely need to not join in. And see, they're going everywhere now. Yeah, honk honk. Big time. Big traffic jam. I would consider that basically a success. We basically did what we needed to do there. So that tells me, for one, I can get rid of all of the drones that are already in the scene. So let's do that. Let's get rid of all of these drone bodies here. We are now just spawning them all instead. We also need to go into hive mind. Let's see. Did we already get rid of the... Oh, it was in the main scene? Yeah. Let's go ahead and trash all of these elements of this array here, because we didn't need those anymore. Let's save, and let's try it again, because again, we're moving away from having them in the scene, and we're moving towards spawning them over time, right? And so far, so good. And if they start doing activities and doing normal stuff, then I know that we're in the right direction here. We definitely want to set it up, though, that that they can't join in on activities while they are trying to do positioning. So we already have some of them that are just idling. They're spacing out. They're continuing to space out. Seems like spacing out is the only thing they want to do. It could be that they aren't finding valid targets for some of their activities. I wonder why that is. It could be that they aren't on the array that lets them be listed as valid for certain things. I think we're checking the list that I just removed all the elements from. Instead of checking the population manager, I think it's based off of the thing that's on the game manager, right? Insomnic Man, thanks for the follow. I appreciate that. But yeah, that's definitely an issue, right? Time to prep since we aren't prepped. We've got some friend detected, but we were just spacing out over and over again, right? Bippy, Teddy, Scrumgus. Okay, it does appear as though everybody is registering correctly, but definitely pulling from the wrong array for valid drones for behavior. Big Friday mood for real, just constantly spacing out. Yeah, that seems about right. Well, I would consider that progress. Let's take a look at where the greasy wheel is there, or where the squeaky wheel is there. Well, the greasy wheel. The greasy wheel does not need the grease. Okay, the squeaky wheel does. I don't want to be adding more grease to the greasy wheel. Jeez. All right, so we've got our game manager registering drones to the hive mind. The hive mind, though, isn't that important anymore. Let's find, or it isn't. It shouldn't be. Well, no, it should be important. It's just that its list of its array of drones. It's all drones array here. I shouldn't be using this for figuring out who can do what, because I think the problem was getting other valid drone is looking at our all drones array, and that's not going to give us what we want anymore, because we moved some of that off into the population manager, because that's something that's always loaded and it has the data version of them and not just the corporeal form of them, basically, right? It's got all of the ideas. So we definitely need to add a function in here that will let us grab a new version of that array, basically, on the fly. Now, I don't think we're doing certify starting from spawn anymore, because we were doing it one at a time. We were doing certify this starter drone instead. Let's do a new function. We want to, let's see, we have get other random drone and then get other valid drone, right? But for the hive mind, those were specifically for things that were in the pasture. So for what we want from population manager here is a function that will return an array of drones that are on the pasture. That way we can determine if those are valid on the hive mind. So maybe something like get all pastured drones. So we are going to declare a variable output. Let's see. And it's an array of Now we were expecting drone bodies before. I don't think I want to be passing references to the actual object, though, necessarily. I would much rather pass around references to their papers, their registration. So let's look at how population does stuff. it passes around drone records. Drone records, those have a reference to the body. So I want to return a list of drone records from this function here. Get all pastured drones. Get all pastured drone records. That's going to be a better name for that function because that's what we're giving. We're giving drone records here. And it should be an array of drone record equals, I think we start like that. So now what we're going to do is go through our population, see if they are pastured, see if their flag is set to pasture, and add them to this array that we're going to output, if that's true. So let's see. And in population, it's all members, right? So what we're going to do is if population dot all members dot size, if it's 0, we want to return output. But why? Let's see. Can I find all members in base population? All members dot size. Oh, size is a function. Wait. Population. Oh, it's called our pop. Okay, my bad. So, if all members dot size and our pop is 0, we're just going to return an empty array, right? However, otherwise, we do for I in pop dot all members dot size. So then we do output dot add, or append rather, our pop all members I. So basically we need to check to see if their flag is set. Let's go var this member equals our pop all members I. Then if this member dot flag is shared flag pasture, then we append the output. Put dot append this member. There we go. That'll take care of that. So that function should basically add everyone who should be pastured. Our pop, communist bugs bunny.jpg. Yes, our population. Our population. So we append that member if their flag is pasture. Then after all that, we return output. So that means any script can call this get all pastured drone records, and that should give them a list of everybody who's in the pasture, right? So now we go into HiveMind. Hive mind gets asked about get other random drone or get other valid drone, right? First thing we should do is we need a way to turn that list of population records into a list of drone bodies. So I kind of feel like that should also be in the population manager, right? So what we want to do then is func get bodies from records. So inside here, we're expecting an array. We want to call this input. And it's going to be an array of drone record is what we want it to accept. Because what this is going to let us do, by putting it here, I could have a function be like, hey, get me all the pasture drone records and go ahead and turn that into a list of bodies. And that means that I won't have to rewrite large parts of the hive mind because it's used to working with arrays of bodies. So we've got our get bodies from records thing. So var output array. This is going to be character body 3D. Equals boop. Then let's see if input.size, if that happens to be 0, come on, regular parentheses, where is it? There we go. Return output. Then we go for I in input.size. We go, let's see, var this body, not their, var this body equals input I dot body, because I think, if I'm not mistaken, drone record body is a reference to the character body, assuming it's set up correctly, right? Input I dot body is this body. Okay. Then we do output dot append this body. Cool. That just sort of converts them all. And then we do return output. So now we can do both steps of getting the drone records that are pastured and getting the body references for them. So in hive mind, rather than okay, so now we have another issue, which is we have all else, get all other drones, this drone. We're going to need a new function here that basically takes the array of bodies as an input. So where is get all other drones? Register waiting, a high weight, connecting drones, other random drone. Get all other drones. Okay, so now we do func get other drones from array. We have this drone, then we have input, which is an array of character body 3D. And it's basically just going to be a version of get all of the drones, except it's checking against the list we hand it instead of against the all drones variable, right? So in fact, we can be more specific than this. There we go. We're a little type safer now. So I'm going to just dump this in here, but instead of for I in all drones.size, we're going to go input.size. And then if input isn't equal to this drone, we append the output with input. Okay, this drone input, then we return output. Cool, we get other drones from array. Very cool. Get all other valid drones. Man. More rewriting. Then I guess we're going to do get all other valid drones from array also. Ooh, an alternative is that we can set all drones whenever we need to call it. I like that better. So rather than having a function where we get drones from an array, get other random drone and get other valid drone, those things, those are going to include, in fact, a lot of these are going to include setting the array, the all drones array, right? So get other random drone. Let's actually do a function in here, which is going to reset our all drones array. So sort of at the top, we're going to do func refresh all drones. And we're going to pass here. Okay, we have the refresh all drones function. What we want to do is go var, let's go with pastured records equals population manager get all, or get pastured, oh man, I don't remember what that function was called. Get all pastured drone records, there we go. Then we do var new bodies equals population manager dot get bodies from records. And we're going to put pastured records in as the input. Then we do all drones equals new bodies. Boom, there's our refresh all drones function. What this will allow us to do is basically reuse all of the functions that talk to our basically all current drones array and fix them by resetting it to the correct values, basically. So remove waiting, test high wait. We've got current idlers, get acting drones. Okay, so this refers to all drones. In fact, we want to find all of the things that refer to all drones on this script. We want to go to the top. Here we go. Certify starting drones. Cool. Refresh all drones. We just made that. Get acting drones. We want to refresh all drones. Very cool. Get other random drone doesn't do it, because we call get all other drones in here, right? Get other valid drone doesn't do it because it calls its own thing too. Get all of the drones though. We refresh all drones. Get all of the valid drones. We refresh all drones. Get watchable drones. Boom. Refresh all drones. I think that'll do the trick. We've saved that. Let's see if it works. Let's see if this does what we want it to do. Are they going to behave normally after we spawn them? Are they going to be cool about this? We'll find out. So they're coming onto the scene. One of the changes I want to make, if we've determined that this works, is I want to move it so that instead of having them spawn and just move in a direction, because currently they're not actually moving to a point on the map, they're moving in a direction set for them at the beginning, because that was the easiest way to get them on the board. Instead, I want them to move to some location on the pasture and have some sort of a system that tells them where they should end up, basically. Ah, they're all just spacing out again. Okay, so nothing, something is not quite working then. I wonder if they're communicating with the game manager by mistake here, because this should work, right? Let's look at the drone brain to see what the issue is. So let's see, end wait. Okay. So we register waiting, we tally set activity mod, start activity. If hivemind.register waiting. No, but they were definitely doing activities. It's just the activity they were doing over and over again was just space out. Right? So the problem could be either start activity or activity mod.pick activity, right? What do we say in start activity? Main state becomes activity, start idle is set to none. Okay. Then we do activity mod.pick activity, right? So let's see, let's grab the activity mod. We're doing pick activity. So if current A role greater than equal to activity rule limit. Activity rule limit is 10. T paper stop activity. I don't remember why that was called T paper. It cleans the roll. Okay. Oh, number of times they want to re-roll the activity. Now I understand. Okay. Activity state becomes thinking. Preference mode is shared random. Pick activity random, else pick random activity. Or, oh, we're picking activity random no matter what. So pick activity random. Pick activity random. Val activities equals default activities. Activity size less than or equal to 0. Has no activities to choose. Brain randomize. Pick index. Valid activities dot size -1. Current activity equals valid activities pick index. Valid activities. So we're picking from all of our activities. Then why are we just spacing out then? I don't know why everybody's just spacing out. That's very strange. I don't have a good explanation for this. They're sneaky, maybe. I'm gonna look at the log here just to make sure that we're not let's see, waiting patiently, space out, because I can understand the first few spacing out, right? Oh no, it says somebody wants to chatter. I think the issue is that they're just in each other's way, so it looks like they're only spacing out, but only because they can't actually get to the people they want to chatter with because they're all in a line. So they're just stuck. I think that's the explanation. Yeah, because it occasionally says they want to chatter. Their options are limited due to configuration. No, it's not that their options are limited. It's that the little bubble that appears above them only triggers when they get to the chat partner, right? So if one of them wants to chatter and they can't actually reach the person they want to chatter with, we never see them do it. But the text box did tell us so-and-so wants to chatter. So it tells me that they tried. They're stuck because they're sandwiched in this line, and they haven't learned how to move around each other, and they don't have the ability to push each other just yet. So they're limited by the fact that they physically can't do any of their other activities because they're not spread out enough. They can't actually navigate to their partner. Oh, physical configuration. Yeah, they can't execute on it. Yeah. Okay, so now I guess the priority problem to solve is one of the next ones, which is how do we use the pasture itself to give them points to navigate to as they're coming out of the garage so that they can be more spread out, basically. So I need to come up with, to make this work, I need some sort of a script that has the knowledge of the size of the inside of the pasture, basically. So I'm basically going to create an area and be like, this is the zone that we're allowed to find coordinates inside of, right? Then I need to decide what qualifies as a valid coordinate inside that box, where, because I'm probably going to want to use a similar system for when they wander randomly, because rather than have them wander in a random direction, it makes more sense to me to actually have them try to wander towards a specific point in the pasture and actually just use the navigation agent to do that, potentially, right? Or at least move in the direction of that point. But basically use this script as a way to sort of validate that the place they're trying to go to is actually inside the pasture, which is what we want. We don't want them to just wander out of the gate or through the garage and off of the map like they currently are. And so I want to use that system to basically pick points that are spread out from each other for all of the drones to path to once they exit the garage. Part of the trick, though, is currently the navigation agent can't see outside of the pasture because I haven't refreshed it, right? So I can't use the navigation agent to get them into the pasture. So there's going to have to be a two-step process of moving in a direction, but then once they enter the pasture, once they're like fully inside of it, then they should go to their assigned location, right? This is getting tricky. I kind of want to use some kind of a one-way collider for the garage so that the navigation agent can actually help them get out of it, right? I probably should rebake it and think about that problem later. Because at least for now, we really need the navigation agent to help them get to their destination. And it's just going to be more complicated if I try to do the other thing. So navigation region, we're going to bake the nav mesh again. I think it still sees this as an obstacle and it shouldn't. So the garage stand-in, use collision is set to off. So I don't know why the navigation agent is not including. Bro. Or maybe it is. I actually don't know for sure. It's kind of hard to say if it's part of the nav mesh or not until we try it. But for now, what we ought to do is, I think we need some sort of an element that defines the bounds of our pasture in terms of size from a position. It'll help us to create another one of these GS box 3Ds, but maybe not inside the level, not part of the navigation region. So we're going to create a new node 3D. Not inside the garage stand-in. It's going to be part of the game manager, part of the main scene. Cool. We're going to name this guy pasture, maybe pasture size helper or pasture helper. Okay, we've got our pasture helper. Now we're going to make our GS. I think is it GS shape or mesh? Let's look at these again. GSC box. Okay. Oh, CSG box. My dyslexia was kicking in. Okay, so we've got a GSC box, or CGS box rather. I said it again. Let's just make it roughly the right size. To encompass our whole pasture. Or we could actually give ourselves a little bit of buffer room. I'm cool with that if y'all are cool with that. Go past our obelisk here, which is really only there to help test the navigation agent, right? And then let's make the height a bit bigger. Okay. And then let's create a new material for it. We're going to make a duplicate of the obelisk material. So we go duplicate, I think. We're going to name the duplicates. Pasture helper material. We're going to assign it to our box. Yeah, okay. We're going to pick a different color. We're going to make it very translucent for now, right? In fact, actually, I don't think we need that to be visible at all. For now, it might help us to have it be just barely visible. So we've got that. And I want to make sure that this doesn't use collision. Okay. So we have an idea of its size. I wonder why the size is a little uneven like that. Yeah, it's a little big there. I do find it interesting that it's not exactly square. Oh, yeah, it's a little tight on this side, too. There we go. It's still not square. Is that going to bother me? Let's just make it 56 by 56. Okay, that seems okay to me. But in terms of transform, let's zero out its position. Okay, that feels better. So we have our size, we have our position there. I feel like a good way to go. I kind of want to. There's a few ways I could try to go about this, right? I can try to do something where, since we know the size and we know the transform position, we could do this thing where we do raycasts from the top and see if we hit the terrain and then report that that's a valid location and do something like that where we sort of randomize and sort of pick random locations or whatever. But I feel like that's not very ordered. It also doesn't give us like an idea of like what valid coordinates are. It just allows us to check if a position is valid, you know? So I kind of feel like the best way to go would be to have a script that takes the size and the transform, figures out what all of the like evenly spaced out locations are by some sort of multiplier inside of its area. Then basically make an array of those coordinates that we would then use. And those would basically be like grid positions, right? Because then we can do stuff like have a system that will cause the drones, as they're coming out of the garage, to move to grid positions in a way that they cannot get in each other's way. Where if we move the faster drones first, and those are moving the furthest distance using our navigation agent, that those basically they'll sort of move into rows, essentially, in like very neat rows. Now they're going to snap out of it after a certain point, right? Because I also don't currently have a system that tells them to stop positioning after they reach their destination. Because currently they don't even have an idea of what their destination is. They just have an idea of a direction they're supposed to move in, right? We still want them to sort of move straight ahead, though, until they are in the pasture. So I kind of want to throw an area 3D. We need an area 3D element that can let them know that they're on the pasture once they enter. That makes sense. Because we want them to move straight until they're in the pasture, then they should navigate to whatever their designated coordinates are. So we probably need a pasture manager script. And I kind of feel like that should be a child of the hive mind. So we do a node. We call this guy pasture manager. We give it a script. We give it a proper path. We call it pasture manager. Lecture size says, Child of the Hive Mind would be an excellent band name. Ooh, that would be an excellent band name. Child of the Hive Mind. Man, that would be dope. That would also be like a good name for like a book series, right? Okay, so let's give this a class name. We've got pasture manager. Did I do that right? I don't know if I did that right. Yeah, I did. Okay. Class name pasture manager. All right. So we've got our pasture manager created, right? Then we need something like a pasture location and a pasture size. And we can set this up in a way that this can be done programmatically, but for now we're going to do it manually, right? So pasture center. It's a vector 3. Oh, we need to declare this as a variable. Equals vector 3, 0, 0, 0. Then var pasture size x float equals How big is this? 56. And programmatically, could we just yoink that information? We could. But like I said before, we're going to do this manually for now. Var pasture size z float equals 56. Okay, so we've got 56 by 56. Now we're going to want a reference to the area 3D, which we're going to make that a child of pasture helper. Area 3D. Now area 3D, it needs a collision shape 3D, right? So we make a collision shape 3D. We're going to make it a new box shape. And, well, we happen to have an opportunity to make it a certain size. How high did I actually make it? I made it 7 before, so let's make it 7. So if I hide that, we can still sort of see the collision box. Cool. Very cool. Now, the area 3D, this has all of the trigger enter signals on it, if I'm not mistaken. Area entered, yes. So the script that talks to our pasture manager should live on this area 3D. Because, and we want to tell the drones that are entering it that they are now actually inside the bounds of the pasture. We also probably want to tell drones that are exiting it that they are exiting the pasture. And that might help solve the problem of how do we keep drones from wandering into the garage or out of the gate and other stuff like that, while like there's no proper collider preventing them from doing so or something. So this needs a script on it then. And what do we want to call this guy? So maybe something like pasture interior. I think I spelled that right. So we're going to give it a script. We want that to be in the scripts folder. We want that to be camel case, pasture interior, create. Very cool. Okay, so we've got our pasture interior. We have our pasture manager. Pasture manager should get a reference to the pasture interior, I think. Well, is there a reason I wouldn't? Oh, I can grab the size and position by the reference, yeah? I could do that. I could do that in the future, though. For now, why would this need a reference to that? I don't think it would need that. Not yet. We've got our size. The pasture manager, I think, or the pasture manager should hold and generate the location, the sort of the coordinates that we talked about, right? So in the past, I've done something like this as an array of arrays. We have an array that represents the columns or rows, and then the other array represents the opposite. That way, it's easy to, well, but do we even need to do that though? I think it makes more sense instead to have a function that can figure out what the extremes are, what the boundaries are, and then something else that's keeping track of the actual coordinates themselves that are being used. Sort of like occupying destinations or occupying locations. I kind of feel like this is also the script where structures that we know that are on the pasture that are blocking specific locations are tracked. Because if the drones were to build like a hay bale on a particular spot, on a particular tile, right, on a coordinate, and it occupies those coordinates, then it does kind of pay to have an array of the coordinates that exist so we can check to see if those coordinates are valid for whatever it is that we're currently doing. And those coordinates, those can have a script that lives on them that can store data. Like if someone is currently pathing there for positioning reasons, now we're cooking, because then we can do stuff like have a function where it's like find next positioning coordinate, right? And then this guy knows which ones are empty and can assign the next one for you. And now we have a location we're moving to and a way to verify that that's an unoccupied space, right? Okay. So we've got an idea then. We probably want to create a class that represents that destination. Sort of like how population has drone records. We want to look at the drone record script as a reference for this. So let's see, where is drone record? Here we go. Oh, so this guy is just, it doesn't extend anything. It has a class name and it has information. So I also kind of feel like this would be a good spot for another enum so that we can check to see if it's occupied, if someone is pathing. Well, those would be different variables, I think, right? So let's make a new script. Create new script. We'll call this, let's see. So this represents data that's stored about a coordinate position on our pasture, right? So one might think of these as tiles or slots or coordinates or something. So maybe I was thinking I could call this something like pasture chord. Now, is that too cryptic? Or should I call it something like pasture tile? Pasture tile maybe works. Pasture space works. Pasture slot might work. I feel like pasture slot is more like a slot a drone occupies and the maximum number of drones you can have in the pasture at once. So we don't want to use pasture slot. Maybe pasture location? But that would be kind of a long name for something that would be passing around a lot. Hence pasture chord, which is short for coordinate. I think pasture chord is fine. So we have our pasture chord script. We need to open it up. Doesn't extend node, but we do have a class name pasture chord. Let's save all. Okay, so the one piece of information so far that I think should be stored on pasture chords is pathing data. Specifically positioning data, right? Like a record of who, well, for one, a pasture cord should have information about where it is, right? It should have a position. And this is sort of where a raycast could come in handy, because then it could determine the height, right? But the other thing too is that if the height changes, or if the height isn't 0, right, then like that's something we're gonna have some control over and can keep track of. And this would be a good place to store some of that information, right? So I think it should have position data. So let's go with something like, well, pasture interior, that's the area. What does the pasture manager have on it again? Pasture manager, right? Pasture center, size. So pasture cord. I kind of want to have a position variable on this guy that represents, if you wanted to path to this coordinate, what is the target position being set to for navigation purposes? So I think we would do something like cord position, or this position, or local. And now we don't want to call it local position because that has connotations. Var maybe something like cord position as a vector 3. Then var, so we've got a cord position. So we do want to store, as we're creating these, as we are instancing them, which we will be doing, we will want to tell them basically what their position is. Because if something else has a reference to it, something has a reference to the pasture cord, they should probably know where that is in space. And they can ask the pasture coordinate for that information if we have that cord position in there. Another thing, we basically need to check to see if it's available for positioning, or if it's occupied for positioning, right? Is someone trying to position to that location right now? So could do something like pause availability, or pause avail. Because I don't want to create an enum that's just going to be basically a Boolean, right? So maybe something like pause avail bool. The problem is the default value of Booleans is false, and we don't want to manually set them all to true. So maybe something like how about a reference to the thing that is positioning to it, which would be null if there isn't anyone referencing to or positioning to it, right? So but there are definitely situations where more than one drone could be trying to head to the same position, just not for this particular mechanic. So it's okay if it's the one variable then and not an array. So what would I call the reference to the drone that is trying to reach this position? Reference to that drone. Reference to whoever is coming to this location. Something like positioner. I mean, because that's it. Like, it's the thing that is positioning. It's the positioner in this case. And I guess we can just go character body 3D here. And it'll be null by default. we're going to save that. We've got our pasture cord. So now pasture manager, we need a reference to this pasture cord variable, right? Populations have an array of drone records. And those are... And I'm preloading and instancing these, right? Okay, pasture manager. Man, I need a reference to something that... Do I need to load it in order to instance it? I don't know that I need to do that. Let's look at population again real quick. Array of drone record, right? Drone record is the thing that is an instant, right? Func register member drone record. All members member, all member append member. It has, okay. So we have population manager as a new pop equals population new. Drone record, carried by 3. Spawner has a reference to started drone collection. Oh, so that probably actually has the thing that we're looking for, the starter drone collector class. Let's take a look at that. Starter drone collection as an array of starter drone. And it's an export variable, and it's a resource. So I'm defining that in the inspector, which I'm not going to be doing. I'm going to be doing that through script. But since it's not a node, I don't think I need to load it. I think I can actually just generate them, because I just defined the class name, right? So we're going to do arrays of arrays to create the positions. We're going to go columns, then rows. So something like var cord columns. It's an array of arrays equals doot. And inside cord columns, the arrays there, the arrays on cord columns are going to be arrays of pasture cords, right? So this is going to get funky. We now need a function that's going to create all of the columns and rows for us now. So func, it's going to be, is it going to be a one-time setup? This could get messy when we're doing stuff like changing locations or increasing the size of the pasture. But for now, we can just sort of assume that this is going to get called one time. We're not going to have to worry about converting one to another or anything like that. It's just going to happen once. So let's do something like pasture one-time setup. And we want to call that, well, first of all, before we get much further, hive mind as a reference to pasture manager, right? It doesn't appear to. Does it reference to starter drone spawner? It does not. Well then. How am I going to reference it? It needs its one-time setup. I mean, I guess we could do an onReady because it's not like we're going to be using any of its coordinates during a ready function, right? So this is going to be the pasture manager equals doot pasture manager. Okay. I'm okay with that for now. Then inside pasture manager, we have one-time setup, and we're going to do that during ready. Doing that during ready. Cool. So we've got pasture one-time setup. This will start by figuring out how many columns we need to create. We create those arrays, then we append those arrays with the number of rows we need, right? So number of columns, we know that the size is 56. I'm assuming size translates to actual units, but the position of what that represents inside of it is going to be to the left and right of 0. So 0, 0 basically represents from the center. 0, 0 would be something like negative 24 or something like that. Negative 3, it would be 28. Negative 28, 0, negative 28, right? We can think about that in a second. We just need to create the right number of rows and columns. Oh, and so then we have to think about spacing, right? Bar spacing value float equals, let's call it 2. I basically want each of these slots to be a 2x2 area for sanity purposes. Because if it's 1x1, anything that's bigger than 1x1 is going to potentially bonk into stuff and cause problems, right? But this also gives us the flexibility to adjust this value and have it still sort of work basically on the fly, right? By having a spacing value, we can effectively figure out how many elements to create by taking the pasture size, dividing it by the spacing value, and then removing the remainder. It's good stuff. So, pasture one-time setup. We need to figure out how many columns. And I guess we're going to do columns as X. Well, let's see what makes sense. We're talking columns, right? The way I see it is columns are going to be as if I'm looking at it from this view. As if I'm looking outside my garage. The columns are going to be laid out like this, and the rows are going to be laid out like this. So with that in mind, we ought to look at the size of the collision shape. So if I shrink it, that's X. So X controls the number of rows. Z controls the number of columns. Because the Z size is the width relative to us. Wider is more columns. Okay. That's what I needed to figure out. Back into the script. So size Z is going to be the number of columns. So var column value equals pasture size Z divided by spacing value. Var row value equals pasture size X divided by spacing value. Now, since these are floats and arrays need integers, we need to round these. So really quickly, I'm going to figure out how to round down our floats. Let's see. Floor and ceiling work for integer rounding. So floor 5.8793 would equal to 5. So basically we're going to do equal to floor. So column value equals floor column value. Then we do, actually what we could do to save a row is we do floor, put it in parentheses. Similarly, can we make this an int? That seems to work. Equals floor this. Now these are both floats. I wonder if it might throw an error there. Do I need to cast it as an int? Wonder how I cast it as an int. I'm going to double check that. So we do int with that in parentheses. Okay, so if I really want to get fancy, we go int and encompass this. That way, we know everything's going to agree, because I don't want to reach a situation where even though I have a whole number, because I'm dividing two floats, it might freak out if it's expecting an int unless I manually cast it as an int, which is what I'm doing here. So we've got that. Got our column value and a row value. So now we need to do basically we make our columns, right? So let's see. Let's go with chord columns equals. Can we just give it can we column value? Is that going to tell us how many records? Can I have an element of type int in an array of arrays? Okay. How do I tell it how many records I want to create? Can I create a bunch of empty arrays? Maybe let's do a for loop. For I, or rather for C in column value. So now we do var We're creating our rows inside this, and then we're going to append, which adds it to the end, right? So inside for C and column value, this is going to be the row array equals, boom. Then I guess we're going to populate the row array here. And then after that, we do chord columns, append, row array. And just so that we're extra type safe. Cool. So this gives us our number of columns, as we would expect. Now we need to do basically the same thing inside here, but for the row array. So for R in row value, so now that we're in there, we do var chord record and this should be a pasture chord. This is a new pasture chord, isn't it? So I feel like I need to load that script, don't I? Okay, before I get any further, let's look at HiveMind and see how they do. How did they do activity scene? But it's a scene, right? It's a group activity. I'm not loading a scene. I don't know how to make a new instance of a script. New instance of a class. Class name dot new equals pasture chord dot new. I'll be damned. That worked just fine. So we've got pasture chord dot new. Then, well, row array dot append row array is going to be an array of pasture chords. So then we append chord record. Onto row array, right? So this gives us the actual individual bits of information that we're looking for. I did something almost like this in a different game prototype in order to keep track of spaces inside procedurally generated dungeons. So this is like a less complicated version of something I've already written, basically. So we're making our columns, we're making our rows. They're being appended in a particular order. So that's going to allow them to predictably be, it's basically going to fill column 0 with rows 0, 1, 2, 3, 4, 5, and just go down the list, right? So let's set some values on pasture chord now. So we know we have a chord position and the positioner, which we know is null. So chord record dot positioner will be set to null. The starter value should be null anyways, but I want to go ahead and make sure that it is being set to null. The other thing we need to set is its actual position, right? Chord position vector 3. So now we come up with an equation that will give us our vector 3 just based off of all these maths we determined before. So to sort of walk backwards, if we're starting at array value 0, 0, so it's column 0, it's row 0, that should be position -28, -28, right? In terms of like vector 2. So what we're looking at is the index. We just need to find, oh man, we need to find we had defined our column value and row value already, right? And that represents the number of columns and rows. So we can't do something as simple as index value times... Oh, we can. We can do index value times spacing value minus half of the pasture size. That will offset it perfectly. Because then the maximum, that should work out perfectly. Okay, we've got our equation. So that was quick. So this is going to be chord. These are good. We're going to set two new variables here. Var chord pause x float equals. We're just going to do equals 0 for now. Var chord pause z float 0. So chord pause x is actually going to be equal to column value is an integer. So we need to cast it as a float. And it's going to be column, oh, we don't have to worry about column value. We have to worry about c, which is an integer, right? So it's going to be float c, it's the column value, times the spacing value. And then all of that minus half of pasture size z, or half of pasture size x in this case. So pasture size x divided by 2. The reason it's minus half of pasture size x is because the center 0, 0, 0 is halfway between the left bound and the rightmost bound. And we don't want to start in the center and then fill in from there. We effectively want to fill in from the upper left-hand corner, which is not the center. It's the far corner, right? And so this should correct for that, essentially, by just sort of bumping it halfway in both directions as a starting point. So we have that, and that means that we can actually do the same thing. So C column value is Z. So we actually don't want this to be C, we want this to be R for X. We want C for Z. Float C times spacing value pasture size z, in case it's rectangular rather than square, right? And that gives us our coordinate position z. Then lastly, we know that the y coordinate position is basically 0. And we can adjust that manually later, but for now, we're just going to assume that it's flat, even though it's not actually flat, right? Row append coordinate record. So we still need to actually set on coordinate record. Where is that? On pasture chord, the actual chord position, which is a vector 3. So we do chord record dot chord position equals vector 3. And inside that, we have our x position, which is chord pos x. 0 is our y position. And chord pos z is our z position. And we append it. So what this should do is basically create a number of slots for a 56 by 56 space, assuming each space is 2 by 2. Now what we probably want to do is print something that tells us we did this right. So we're gonna throw a print statement in here for now. Print creating chord for position, and then we do string. Inside that we do chord record chord position. Expect a closing blah after arguments. Oh, we need a plus here. String not found in base self. Okay, we need to figure out how to convert to string. Specifically, I'm trying to turn a vector 3 into a string. Let's see, virtual method called _to_string. Oh, str. That should do it. Well, that was easier than actually typing in string, I guess. So even though I'm not really using pasture chords yet, this will tell me if I wrote this correctly, because when I hit play, it's going to print basically a whole lot of coordinates. Let's see if it works. Boom. Let's pause it. And we need to look at what? Output? Hey, here we go. It created -28, -26, 24. It just went and created all of those positions. -28 all the way to +28. Or all the way to +26. Okay, so I already see a potential issue, which is because I used the array, the index, that goes from 0 to whatever. There needs to be an offset of half of the spacing value, I guess. But for now, this is pretty close to correct, right? It created all of these positions, all these records. I wonder though, -28. up to something, then 26, then negative 24, then 22, 20, then to negative 18, and then it stopped doing that. Why did it stop at negative 18? I feel like that stopped really prematurely. Let's unpause. Does it go any further? No. Why didn't it continue? That's a little strange. Because it should have gone all the way to the point where this was at. Huh. I don't know why it stopped so prematurely there. Well, let's see. Column value for C and column value, array. Print, row array, append, chord record. Chord columns dot append, row array. That's weird. Oh, there was an error. Output overflow, print less text. Okay. So the output couldn't actually handle the number of times I was printing. That's funny. It basically worked. Okay, so we're doing float r times spacing value minus pasture size divided by 2 plus spacing value divided by 2. We're going to do that. And I guess instead of doing that for every single slot and every single row, which caused problems apparently, we're going to print, I guess, only sometimes. Nah, I want to just run it again. I just want to make sure that the coordinates are closer to how I want them to be, right? So immediately got an output overflow again. Well, let's look at output. Yes, I get it. So this time, what were the actual positions it chose? 27 up to, yeah, negative 27 to positive 27. That's closer to what I wanted. Okay, I no longer really need that print statement anymore because it's clear to me that it worked. It just didn't like it. It didn't like printing all of that. To be fair, I'm asking it to print a lot of stuff, like how many records is that? 56 times 56, maybe divided by 2. 56 divided by 2 is 28 times 28. Yeah, it was going to try to print 784 records because that's how many positions there are in this array. Now, that might be too many. That might be a little bit too many. Well, this is where some of this flexibility comes in. Let's change the spacing value to, I don't know, 4? And let's try again. Is that going to be too much? Half as many? So now if we pause, I didn't get an output error this time. As with a spacing value of 4, we went from 26 to 26 with way fewer records. And it printed the whole batch this time. Okay, so spacing value of 4 is maybe a little bit more reasonable, because that's 196 records. That's a fine number of records. So we've got our grid now, essentially. We have all these positions we can tell them to move to. So now if I tell the first drone that its destination is whichever coordinate is located on column 0, row 0. We should probably, on Pasture Manager, create a function for getting a specific pasture coordinate. So maybe func get pasture cord by position. And we're going to use the by position. What do we want to pass in there? I kind of want to go integer, because then it's going to pull out of there like a chart. If I say, hey, get me coordinate number 5, and then it's going to go based on the columns and rows, right? And give me a spot that's sort of far away from my start zone. So not chord by position, get chord by rank. Get chord by int. Get chord by int, right? Input int. So what we're doing, we're basically taking an integer value and sort of pretending that all of those chord positions exist on a single array and iterating through them until we find a coordinate by that value. The reason we're putting this function in here is that the method on, I guess it would be the spawner or maybe HiveMind, that's trying to find coordinates to send these drones to, doesn't want to fuss with having to know what the column and row numbers are. So instead, it's going to just sort of pluck a record from a value. It's going to basically ask this script to give it a specific record instead, right? So I guess the first thing we want to do it also makes sense to me to store these column and row values on this guy as variables. No, I can just figure that out by reaching into the array, and that would be safer. So we do, because there should be a safety check here to make sure the int we're getting isn't going to try to cause us to grab something that doesn't exist, right? So var, let's go with, the array is chord columns. So this is the number of columns. Equals chord columns dot size. Then var rows equals chord columns 0 dot size. Because chord columns 0's size will tell us how many rows, right? Then if input is greater than columns times rows, return null. So we're returning null here only if the thing that they're asking us to find does not exist, basically. So then we have to divide input by the number of columns. Well, I guess we divide input by number of columns and round down. Because we're trying to grab a particular slot in this array of arrays. This could have all just been one huge array, couldn't it have? That would have been more complicated. Or it would have been complicated, but in a different way. Okay. I have to do some math here. Because if the input is less than columns, we could just pull it out of the first column. Otherwise, we're going to have to do some division, right? So if we divide and we round up, I got to think about this. Okay, we got to divide, then round down, then find the remainder. And then that tells us the column and the row. That's what we got to do. Divide and round down. So var column pause equals floor input divided by columns. Cool. So we have column pause. Actually, this ain't quite going to work because input, if we get 1, it won't give us the first record. It'll give us the second record. We actually want to treat input as an index. So we should be expecting an index, which means the thing we should be checking this against, because if it's 1 divided by 1, Dang, this is tough. I'm very likely to screw this up. What am I actually trying to do here? The thing I'm trying to get is I'm trying to get the next empty coordinate. I'm trying to get the next empty coordinate. I don't have to know. I don't have to be able to pull something up based on a number in order to get the next empty coordinate. Do I? So it occurs to me, another thing that makes sense, as much as we want a coordinate position on this guy, we also want to know basically its indices for its column and row. Because that'll make it easier. If we have a reference to the pasture chords, it'll make it easier to talk to. It'll make it easier to fetch it, I think, or whatever, or know what to call next or something. I don't know. Bar row index int. And then as part of pasture manager, while we're setting this up, we ought to chord record dot column index equals C. No, it equals C. Chord record dot row index equals R. Oh, not core record. Chord record. Okay, this could come in handy later. We're going to save that. So rather than trying to do something like get pasture chord by int, which is melting my brain right now, we will eventually do get next empty pasture chord, because that's going to be more reasonable to do. Because then we can just iterate through the array, check to see if that variable is empty, and as soon as we find one that is empty, we pass a reference to that coordinate, which will include the position. So we're going to do get next, not empty though. On pasture chords, it's positioner that will be empty, right? Next positionerless chord. Iterate through the arrays to find one that is empty. Okay, so we're going to save this. And I think this is going to be a good place to leave off. Now I know this is not going to be as satisfying as we were hoping for by the end of the session, because they are not moving to the positions that we want them to move them to. They're still traffic jamming it up. But this is still progress from before, and I think if I do put some time into it on Monday, maybe even over the weekend, but most likely Monday, I'll probably have this in a state where they are pathing to their coordinates. Or at least doing something like that, right? And that'll be a good spot. Anyways, that leaves us off for today. Thanks for tuning in. It was awesome to make some progress with y'all, and I'll see you Monday. Bye bye.